just a minute and we start. Oh yeah, can you stop sharing your screen in the meantime? Awesome.
Sure.
Then I'll give you a short intro and then you can jump in to your screen. All right, let's begin. Hello, everyone, and welcome to today's Supernova workshop. My name is Andrew, and I work at DFINITY as a developer relations engineer. Before we go on, let me just say that the session is being recorded, and it will be available on DFINITY's YouTube channel. Today, we are lucky to have Austin Fatheree, the CTO of Origyn. Origyn is one of the earliest teams who have started developing on the internet computer, and currently the only one, if I'm not mistaken, who are connecting NFTs to real-world objects. But they're also working on many exciting things that I don't have time in this short intro. Today, Austin is going to talk about HTTP certification on the internet computer, an important and interesting subject. So without further ado, Austin, the stage is yours.
Awesome. Hello, everyone. I appreciate everybody who hopped on, and I hope this will be a useful time for your project and as well for your general understanding of how the internet computer works. This topic is really, I think, kind of one of the hidden corners of the internet computer so far. And the tooling that we have in this area is not robust. It needs to be developed. And but it's still a very powerful tool that you can use and will help you think about how to think like the internet computer. My name is Austin Fatheree. I do a few too many things. As Andrew mentioned, I'm CTO of Origyn. I also am the executive director of IC Devs. IC Devs tries to put out bounties and support the community and do various things, like focus on the development experience, the developers in the community. So we've been a bit swamped lately, and we've mostly been sponsoring the Quick Start Bounty program. Now that Supernova is going, this has most of everyone's focus. But once it's over, IC Devs will be picking right back up with quick starts and bounties and all sorts of fun stuff. So we encourage you, as you run across things like we're going to talk about today, please, if you have a problem that you think everyone is having, and it's a discrete piece of work, that is an awesome thing to send to me, and we can build a bounty around it and get it sponsored and put it out into the community and try to get somebody to build that for everybody. That being said, that's kind of a part-time deal. My main job is CTO of Origyn, and we're hiring like crazy. So if you find this stuff interesting, please reach out there as well. Now, the thing that people sort of, I don't think many people have realized yet, is that the internet computer can serve the web. It serves HTML, and it serves it in a certified manner, meaning that there is a way that it serves it that you can trust the data coming out of it. You can trust that no one's fiddled on the back end and no one's changed something. That if you're reading someone's comment, that's their comment. We're being recorded. You missed a wonderful intro if you're just joining the stream now.
We've been live on Twitter and YouTube and the whole time, so I think it is recorded, and it's just that the Zoom has started recording as well. So
awesome, cool,
we're good.
So the internet, your canister can serve HTML and can serve all sorts of data types, and I'm not just talking about like an asset canister. An asset canister is something else. Your backend canisters also have an HTTP endpoint that you can serve HTML from. And we're going to talk about that today and walk through some examples. So I am going to share my screen, make sure I'm on the right thing here, and then I'm going to share my screen. And my screen that I have to use for sharing is over here. So if you feel like I'm not looking at you, that's why.
Looks good.
Good. Okay. Here's some more of my intro stuff. We already talked about that. So the points we'll hit today. You have this HTTPS endpoint for each canister. That means you can hit your canister ID .ic0.app and serve content. You can also set up your own ICX proxy and serve something from your URL that's then routed to the IC on the back end. So if you see apps right now that don't have a nasty URL, they're probably using an ICX proxy in front of the internet computer. You can serve all kinds of files from this endpoint. You can serve images, you can serve video, you can serve video is hard, but you can do it. You can serve text, you can serve PDFs, whatever. Anything that you can serve from the internet, you can serve from your canister. Right now, HTTP requests are GET requests. And they're GET requests from an anonymous source, from the anonymous principle. You can't make a GET request from your plug principle. Not yet, not very easily. Now, there's a lot of tooling that we envision building where you can have a more traditional web services based interaction, and you could actually submit an identity in the header or something like that, and it can be converted to a principal. There's lots of things that we can do in the future that we just need great tooling for. And we actually have a bounty that we're looking at doing after Supernova around sort of a different way to sort of tackle the internet computer in a more of a Swagger-like fashion than the typical JavaScript agent. But that's in the future. Right now, it's all GET requests. You can, as of a couple weeks ago, I think, do an upgrade request to your request. So what that means is you request the GET, and then your server can say, hey, I actually need this to be an update request, and the ICX proxy will revert right back and tell you, okay, you can here's the update request, and now you can change state. But unless you return that upgrade request, you can't change state by hitting a URL. And then you're a bit handicapped, because even if you do use the update, you're updating in the anonymous principle, and so it's not a user interactable type thing just yet, unless you implement your own scheme.
So this is similar to a post request?
Right. So you can do a post request. It's really not a post request. It's more like a GET request that can change your state. I guess you can simulate a post request, but
it is similar. It has the effect. Exactly.
So this means that if you're doing an NFT collection, your NFT collection can host its own website. It can host its own content, and I'll actually show you an example of that later. You can sign your content, and users will know that it was not faked, that it actually came out of your canister. Now, how you implement your canister and what you accept to come into your canister is your own story. But if it's an open source canister and people trust the canister and trust that it's secure, you should be able to trust the content coming out of it as well with this digital signature. What the certificate means is it means that the whole subnet agrees that your data is your data. And that actually rolls up to the internet computer as well. So this is cool because we can have people create content, we can put content in the internet computer, and we can trust when it comes out that it's actually that content. You can still do lots of cool things with this endpoint without doing certification, using the raw endpoint. So you will have seen, especially if you use something like Discover, that there's a raw in the URL, and that means they're not certifying the content that comes back. There's a lot of reasons to not certify content. First of all, it's almost impossible to certify dynamic content, and it's definitely impossible to certify comment from a query. Because if you're building dynamic content, you have a timestamp, there's no way to certify it before it comes back to the user. So if you have a page that's constantly changing with dynamic content, the likelihood that that's going to be certified is low, because you'd have to certify a potentially infinite number of things, and that takes cycles. So to the code. First of all, almost ubiquitously, this code was borrowed from Joachim Brittner, who wrote a lot of this stuff very early in the Internet Computer's life cycle. I took some of it and just made some examples out of it, some progressive examples out of it, but it's almost entirely his code. If you haven't looked at his GitHub, it's worth going and spending some time there. He also has the premier article on building Internet Computer applications and auditing them. And if you're building an application and haven't read it, then you're doing it wrong. So you definitely need to go read that. So I have a Motoko playground here. I'll put these links somewhere, but there's 3 examples that we'll go through. And I'm going to go ahead and I'm going to deploy. I'm going to deploy this, and then we'll talk about it. So I hope everybody's gotten acquainted with the Motoko playground if you're doing Motoko. And we got a canister. So if I go to this canister, it's going to install a service worker, and it's going to tell me that your body does not pass verification. If I go to raw, put a raw in here, I get something. It says this canister demonstrates certified HTTP assets from Motoko. You can see this text, and it gives the URL, and it will validate. The last message submitted was nobody said anything yet. So we have a message thing here called leave message. And if we type something like hello Supernova, call that. We go back here, take the raw out and refresh. We can see that instead of getting does not pass verification, we get this same thing with hello Supernova in it. So now I'm going to walk through what code allowed that to happen. So we start off with no message, or a message that says nobody said anything yet. And then we have our super simple function for leaving the message, where we set that last message, and then we update our asset hash. We have a function here called main page, which just produces, in this case, it produces some text. So we have some straight up text where we inject some data, basically the ID, and return or put the last message at the end of it. Now there's some tools and some structures you need for serving HTTP requests. You have header fields, which are just a tuple of 2 texts. And so if you've ever looked, inspected an HTML request, you see headers like cookies and refer and all these things, and that's where those things will come in. And then you have to send back a response, which is just a status code, its own set of headers, and a body. The status code are your typical HTML status codes like 200 and 404 and all that. When you get a request, when somebody requests that HTTP endpoint, what happens is the ICX proxy gets it and it converts it into the HTTP request candid structure, and it passes it in here. This is one version of this. We have we had a bounty at IC Devs, and a user created a library to parse these HTTP requests to give you some helper functions that you typically need when building a web application, like query string parser and a body parser and a bunch of other stuff. So I'd go if you're going to do some of this, you want to look. I didn't use that example. I didn't use that library here, but you can get a lot of power out of the HTTP request, because this is pretty raw. The URL is just one big text, and the body is a blob. So you got to parse. If something's being passed to you in the body, you've got to parse it out yourself, and there aren't a lot of great parsing libraries from Motoko yet. Here's where we handle the request. We handle GET requests, and all we're returning is 200. We put that this content is plain text in our header, and then we have another header that's written that's a certification header, and we'll look at this function in just a bit. And then we return back the main page. And keep in mind, this main page is this main page function up here. It's deterministic, so it'll be the same every time, provided the underlying data of the canister doesn't change. The certification is held in a tree structure, and there's a couple different of these tree structures out there. This is a simple one. And I'll go more into trees and how you use them. But this first example, we only have one value that we're certifying, which is the main page, and so we don't have to use the tree a whole lot just yet. Our tree is going to be very simple. It's going to have a labeled asset. It's going to reside at the root, and its leaf is going to be main page. This asset tree has we're going to set the certified data to this hash tree. So we update the asset hash. It will call this function. It'll look at our main page, see what text is in it, and then put it into our certification. The certification header uses the certified data API to look and see if there is a certificate, and if there is, it puts this magic header into your HTTP response. And this magic header is used by that worker process on the ICX proxy to certify that the data was signed by the internet computer. And if it doesn't pass, if the data doesn't match, you don't get served the page. And that is really it. There's a bunch of other stuff down here that you can go explore on your own, including some basic CBOR encoding for some of these things. But I'm not going to get too in the weeds here on that. The moral of the story is we have this page. I can go, and if I update this, it's gonna certify the new data, and it's still let through even with the new text. So that's example one, certified data. Let's see, let me make sure I hit everything on here. Are there any questions before I move on to example two, where we evolve this example to be a little bit more dynamic? No questions?
I have one. I don't see anything from the audience just yet.
Sure.
So if I create my Hello World app, do I need to specifically write this myself, or would this be that's the question.
So the typical architecture that you use is and the way DFINITY's library sort of set your Hello World apps and things like that up is using an asset canister and a backing canister, right? So that's nice because the asset canister takes care of all of this for you. It certifies all of your HTML, your JavaScript, your CSS. When you publish that, it sort of does all of that for you. And that's a fine architecture. And if you do that, that's great. The backend data is sort of implicitly certified because especially if you're accessing it via update methods using the JavaScript agent, it's going to get certified for you on the way out anyway, because it's an update function. The result of all update functions are certified because of how the internet computer works. But query functions are harder, and you can't super trust them, right? And so this would allow you to create the main application for this is more realistically dynamic file sharing, or file sharing on the fly, where your canister is actually producing new content, new files based off of user input that need to be served up as either text files or image files or whatever. Also, if you want to write a more traditional Web 2 service, or like an RSS feed, for instance, then every time you add a file, you could certify the endpoint, the new RSS endpoint content, and then you could have an RSS feed. So that's that. You don't have to worry about this stuff until you really start looking at, okay, I want to build a robust utility to be used across the internet computer. That's when you really have to start worrying about some of this. And I hope all of you are doing that in your Supernova projects. We need lots of public utilities on the internet computer. We need lots of libraries, and we need those libraries to have certified data. So if you're building a cool note-taking application, you probably don't need to do this, unless you want to serve the notes directly out of your backend canister in a certified way, and that's where this would come in.
And also, if let's say you're building an image editor in the browser, that would maybe upload some of the images, and then you serve them back to you, and then you edit, change them, and all this.
Yeah, or even more dynamically, if you built an image editor inside of a canister.
Yes. So we have one question from the audience. That is this code going to be available, or do you have it somewhere in the repo?
Yes, it's not in a repo, but it's on Motoko Playground. So worst case, if you play this back and zoom in on these little tag numbers and punch them in, they'll load up in Motoko Playground. Best case, I'll remember to tweet them out later. But
can you copy it into the chat here? I guess that's the simplest.
Yes, let me keep, where's chat? No Q&A chat. So the first one is here. And the example we're about to look at is here.
And before we go on to the next example, let me interject a second question from the audience. That is it bad if we host on Web 2 to counteract the delay until HTTPS requests are available?
Say that again.
Yes. So is it bad if we host on Web 2 to counteract the delay until HTTPS requests are available?
I'm not sure I follow.
Can you rephrase that in the Q&A or in the comment section, and then we can move on, and I'll ask later once the audience member has rephrased the question. Does that sound good?
Hackathon specific question. I think I understand that. If the internet computer has a delay, right? It's a hell of a lot faster than Ethereum, but still users are used to waiting about half a second to 1.5 seconds for their web apps to respond, or their mobile apps to respond. And if you're doing anything of any kind of significance, you're realistically looking at a 2 to 4 second delay making an update call to the internet computer. So what you should do if you're building a Web 2 application that uses the internet computer as your backend, which I think we'd call a Web 3, application, you want to simulate things for your users. You probably want to be optimistic, and you want to, if you click submit and you send it to submit a comment, show the user that their comment was processed. You can always come back later and say, uh-oh, it didn't work. But 999 times out of 1,000, it's going to work, and your user is going to have a great experience. And so that's the strategy I would use there.
Basically, can cheat on the front end to say everything is fine and just move on, and then
totally cheat. As long as there's not financial implications, you're probably fine doing that. If you're building
your transaction went through, don't worry.
Yeah, if you're building a financial application, you probably want to be a little bit more transparent with the user.
Yes, but then if it's about transactions, maybe the user wants to wait a couple of seconds to make sure. So then it's not a problem.
Exactly. Okay, I'm going to start up Motoko Playground example number 2. And we will see that our signature is a little different. Now we can add a page. And instead of saying something, we're going to add a page. So do y'all see this microphone? I never know if y'all see this Zoom bar, but it's in a really bad place.
No, Zoom is pretty smart at hiding everything in, when you share your screen. We only see our code and the browser.
Good.
Just let me add something to the previous question while you're hacking, that we generally want everything to be served on the IC when it's possible. And it is advised because the IC is such a unique opportunity and so powerful to be able to serve web content on the blockchain. But if there's some very unique feature that you're looking for and something very specific to your application that is currently impossible on the IC, then of course you can or you should be using Web 2 technologies. For example, real-time online multiplayer is currently quite hard to get right on the IC because we don't have the WebSockets and things like this. But other than that, it's usually advised to try to work around the way the IC works and then make sure that you're using all the tools available that the IC gives you, and then serve the content on the blockchain, on the 100% on the blockchain.
Yeah, we're making some pretty big bets on Moore's law over the next 3 to 5 years. But if you'll never get sub millisecond or it's going to be very difficult to get sub-second response out of the internet computer just because of the consensus mechanism, but it'll get progressively better and less noticeable, I think. Okay, so we have our second example, and our body doesn't pass verification because nothing's been sent yet. But I'm going to put something here, and I don't remember if I need to put a slash or not, so I'm going to put test. I think I have to do this. Okay. So now I'm able to upload text pages. So I can do test 1, 2, 3, and I can say hello Supernova. And I can call that. And now I have a page at test and a page at test 1, 2, 3, and they're both certified. So now I can serve multiple items, and you may be able to begin to see where we're going with this, but this is sort of how the asset canister works under the hood. So what are we doing different here? Well, when we serve our HTTP request, we serve up this main page, and that doesn't seem right at all. This is just the root, right? So If it's just the root, we serve up that old thing we used to do. If it's not at the root, then we're gonna look in this pages map, which is a tree map of text to text. Try map, I think, maybe. I'm not sure. This is like a collection, and so this text maps to that text. And so when we do this, we're gonna, you know, be pretty simple here. If we don't find that, we're going to return a 404. If we do find it, then we are going to return our certification header, and we're going to encode that UTF, that page as UTF text, and send that down the pipe. Our certification header is going to look a little bit different. I guess that actually looks fairly much the same, but the asset tree is a little bit different. Basically, what happens here, we're cheating a little bit, and we're building a very sort of lopsided tree, certification tree. For those of you who are sort of unfamiliar with Merkle trees or hash trees or those kinds of things, just a quick overview. A lot of the magic of blockchain comes from the fact that if you have 4 values, and you do this hashing mechanism where you take these unique hashes of these and you hash those unique hashes together, you get a top hash. If you need to prove L3, all you need is this path. You can cut this data out and you can cut that data out, and you're left with a very thin piece of data that has a proof that that piece of data is a part of the master set. And so when you have an Ethereum root, you can prove a variable in your smart contract is a part of the current Ethereum root by having what's called a witness. And this pathway is the witness. And so what we're doing here is we're making a very lopsided tree where we just kind of keep going off the right-hand side here, and adding things to the right. And we go through all of our pages and we add a leaf on the right-hand side of our item. And then when this is all done, it gets hashed up into an individual certificate that gets written to, I guess we need to find the add page function. Okay, we update the asset hash. So every time we put one of these things into the tree, we update the asset hash. And that way we can build as many of these text pages as we want on our canister. We can serve all of them up through HTML. Now, this will eventually degrade in performance because that tree is going to get so heavy on the right side. What you typically do is you want a better data structure that allows you to put things at leaves and then, you know, redistributes things as your data set grows. Ethereum uses a Patricia tree, which is sort of a predefined structure, so you don't have to do a lot of reorganizing. I don't think we have a Patricia tree structure for Motoko yet. So if you're looking for a project for Supernova to build, whenever we all do get together at a cool conference or something, if you wrote that library, people would come and give you big old hugs.
Free bear.
Yeah, big bear hugs. So make sure you're ready for that if you write that library.
We also have a question from the audience.
Sure.
I'm not quite sure the question means, but I hope you will. What's the audit technique to follow?
What's the
audit technique or technique to follow?
Oh, that's Joachim's audit. Spoiler, he audited Origyn's governance investing canisters for us, and afterwards wrote a very detailed article on all the things that he learned about auditing a contract. And so there's an article. It's like here it is. This is the article. Definitely worth a read.
Thank you.
Okay, so that gives us this sort of superpower to build this unbalanced tree, and if we have the right data structure, we could build a balanced tree. I have one more example where we're going to level this thing up just a little bit, and then we'll take some more questions. So I'm going to go here and I'll paste this over here. Deploy this. All right, body does not pass verification. Cool. So now we have adjusted this a little bit. Our pages is now, it used to be text to text, and now it's text to page. How is a page different? Well, a page is made up of both text and content type. So when we add a page now, we not only provide /test and a bunch of text, we also provide content type, and this is just a standard HTML content type. And we'll click call there. And now if I go to /test, I get a certified SVG image. And so you can imagine putting, I don't remember, I don't know these by heart, text HTML, and putting in that may not work, but we're going to try it. I'm going to code on the fly here. There we go. So now we sort of an HTML page, right? We can, I need to work on my HTML. What did I do wrong?
Live debugging, perfect.
Oh, weird. There's like a, I use Notepad. I freaking hate this. Apple's so ridiculous. Okay, sorry. I pasted out a Notepad and it replaced my quote with like a fancy quote. So it didn't work. I apologize. So this example is really just the exact same as the last one. It's just that when we do our asset tree, we are find the right code. I guess it's just our hash tree, asset tree. Okay, all right. So we do the same thing. We loop through our entries, and then at the end, we put the text. we don't have to certify the content. We don't have to certify the content encoding because it's not part of the body. So what we do here is, I guess we need our HTTP request. When we return our, this is the magic here. When we return our request, we look through our tree, our pages tree, and get the URL, and we set the page contents to the content type. And that's it. Really a very simple change. It gives us that much more power to serve cool assets from the internet computer.
Would this cause performance issues if, let's say, I have a page that has the structure of my decentralized Facebook / and the username, and if I have a million users, then it would have to loop through each of these users to get the content type?
Well, you put it, so the purpose of a tree data structure is to get to that data quickly. So it's actually, you know, a tree map uses a similar type structure to this, where it comes in, it says, I'm looking for DOM, right? I have this, it says the left branch is A through H, and this is H through Z. So I need to go this way, and then I go this way, and then I finally find my root. And if you think in multiples of 2 or factors of 2, yes, the bigger you get, but like once you get to like 6 levels, you can add a heck of a lot of data without having to go down to the 7th level. The tree structure should help you do that. Where this gets performantly dicey is that when you do a real Merkle tree structure, when you change one user's data, you have to update the tree all the way up to the top. Now, fortunately, it's only one pathway to the top that you're changing, but you have to change all of those hashes all the way along your path to get to the top and create a new root that you can certify. And so it would increase your update times whenever you push the data in, so that you can recalculate the tree roots along the pathway that you need, the hashes along the pathway. Does that make sense?
Yep.
Okay, and that's it. So this allows us to do cool things like, you know, our stuff we're doing for Origyn NFTs, where we're able to, you know, put web pages inside of our NFTs, and serve content out of our NFTs. And so we're actually not certifying this yet, but certification is on the pathway for the things that we're serving from nft.origyn.network. Lots of cool stuff, lots of cool applications to this. And I'm happy to answer any questions and or accept any criticisms. If there's something I can talk about more specifically next time that I give this talk, I'd love to hear it as well.
All right, maybe we can wait a little bit if someone has questions or criticisms. They can poke some holes in your explanations, maybe. No, I think it was pretty clear. So no questions can also be a good sign.
Great. Okay. Well, again, if you're looking to get into the Web3 space, and you know, we're looking for highly qualified general full stack developers that are eager to get ramped up on Motoko and jump into a project that has a significant amount of momentum behind it. And we would love to hear from you. You can reach out to me on Twitter, or I'm on the dev Discord and also the dev forums. I'm pretty easy to find there.
One question that is there something that you would like to see out of Supernova? Is there some projects that you wanna have developed and it's not out yet?
Yeah, I mean that's an easy question for me to answer because I've been driving the bounties at IC Devs a bit, and so
You have a list of it.
if you check that list, those are things that I want to see come out of Supernova. Um, I'm working on a project that I don't know if I'm going to be able to finish it or not because we have a number of things going to production recently, and it's drastically hamstrung my productivity. But we're working on a kind of a general event notification application that could be used for things like being notified when new transactions hit the ledger, or when a new post is created somewhere and you want to subscribe to that in a performant and distributed way. We're building a service to do that because we need it ourselves. When these NFTs go on sale, we want to tell everybody they're on sale, right? And so we have an internal team that's working on that with some help from some outside contributors. If we can get a good demo of that out, I'd be super happy. I would love to see just some, and it's a bit of a, the categories are sort of application specific, but we really just need some general tools for the internet computer and some general libraries.
Yes. So let me ask the same question, but let me limit you in your response because I see you're really infrastructure and tooling focused.
Yeah.
So if you can't choose anything regarding tooling and infrastructure, but you would have to choose an application or dapp, what would that be? That would like to see? Because, for example, Bob said that he would love to see Bob Bodley, a Tamagotchi on the IC, an NFT Tamagotchi. That is, and that's his dream that someone develops it.
I can build that for Bob. What do I want to use? I've had some really strong communities that I've been part of in the past that just had a good vibe and allowed you to connect to people and feel like you had a connection. And the last couple of years have been so hard on that front. We have things like Discord and other stuff like that. They're so noisy and they're so purpose driven. They're not comfortable spaces to go. You get spammed. You get everybody shilling something, and so the nice thing about the IC is like for $5 you can run a massive social network for a year, right? Like let's have some comfortable, safe social spaces that we can go to that nobody's trying to sell us anything in, and it's just a bunch of friends posting dumb pictures and or pictures of our kids, or all the things that Facebook was in the first 9 months of Facebook that got everybody on it, that it isn't anymore. That would be really amazing if I could reconnect. I mean, I'm disconnected from my family. I'm more disconnected now from my family than I was before Facebook, because some unfortunate members of my family are unfortunate social media users and use it for purposes that I don't want to use it for, and that I don't want to hear about, and that are poisonous to our family and our friendships and everything else, right? Like, chill out, everybody. Let's have some fun and post pictures of our kids again, right? Without Pepsi trying to stick an ad in between the two pictures where our kids are drinking Coke. It's dumb. And we have this amazing tool to do it now, and it's just super cheap to run this stuff right now. And I think that's what I'd like to see.
I absolutely love this. And I think most communities or most social media websites start out like this, and then not always, but sometimes people are the ones breaking this dream, because they are the ones who first start chilling. And then if it's on Web3, then NFT projects are going to go everywhere, and everyone is trying to sell theirs. Maybe even Discover in the beginning was just about nice conversations and friendly comments, and now it's the landscape has shifted a little bit.
Yeah. So I know Kevin Owaki, who founded Gitcoin, I think it was him. I don't want to misquote him, but I think it was him. I think he posted something the other day. It was something on the lines of, can someone solve for making sure that no one gets attention for the things the bad things that they do, and only get attention for the good things that they do? Like, can we create a social network where,
perfect incentive structure?
Yeah, with a perfect incentive structure, so that we hear about all the amazing things that are happening and none of the awful things that are happening. If you can solve that, then let's go build it.
Then you're the next $1 billion company in the IC, or not the next, the first. Yeah.
Yeah.
Yeah, I'd love to see that as well.
Hey, maybe the first.
Yes.
All right, cool. Well, thank you everyone for attending. Blow up my Twitter if you have any questions, and love to keep talking about this stuff. And please, like, IC devs, if you have a bounty request and something that you can't build but needs to be built, like, send it to us, and the chances of it becoming a bounty are fairly high, right? Like, we just got to get it approved by some folks and make sure we have enough cash allocated for it. And we're not offering $25,000 grants yet, but some of them are pretty sizable, and when they actually get built, really help the community. So look forward to hearing about those.
Awesome. All right. Thank you everyone for joining. And Austin, thanks a lot for this nice presentation and a workshop. And yeah, hopefully we'll see each other in a couple of months in your second workshop.
Yeah, sounds good.
Okay. All right. Thanks everyone. Cheers.
Thank you so much, Austin. Thank you.
Bye.